What's going on, everybody? Welcome to Docker for Beginners hands-on course by Teddy Winters. So, most of you might now be knowing what Docker is, what Docker does, etc., and might not have found a good hands-on tutorials, which is why you are here. And rest assured that I will be making my best to understand you, to make you understand how things work in Docker. So basically, all I can say in simple words about Docker is a kind of an operating system for containers. And speaking about containers, containers are something which wraps up all the dependencies and packages to run your software applications. So irrespective of whether those packages and applications and dependencies are found on your system or not, by running this Docker containers on your systems, you'll be able to run that application. So yes, let's get started. So what shall we demonstrate today? In each and every video from now, I will be teaching you about one or two important keywords that we will be using in the Docker file, which is basically the blueprint of the Docker containers. And we will build the images and we will run the containers. And in this tutorial, I will be teaching you two things. One is the from and another is the run keyword. Okay, so now I'm in my local Ubuntu machine. So I would like to run a command first, ls, which will list me out the contents of that particular folder. So there are two folders and there are subfolders, and again those subfolders are having files in it. And there is one more package called a tree. And if I say tree dot, which is currently not installed, this tree basically gives me the tree structure of the folders wherever I am currently now. Okay, so now what I will do is I will go ahead and create a Docker container of the same Ubuntu operating system base image, which will have this package installed. And we will see that this, my local machine, my local Ubuntu, will not have the tree package, but the container instance that will be running will be having the trees package, and it will be showing me the structure of the folders. All right, so let's get started. So I'll create a folder. I'll call it as mkdir docker-tree, and I will navigate over it, and then I'll go ahead and create the Docker file. So this file has to be named like this. You can name it anything and give that this thing what they say, then file name while running that command, but this is the standard. Let's follow the conventions. Vi Docker file and I for inserting. So the from keyword will create the underlying base images for building up your libraries. So I will say from Ubuntu. Let's come out and let's build this Docker image. Docker build. I will give some name and I call it -t uh, demo tree space dot. So now you can see my Docker image has been successfully created by building this Docker file. Now I will run this instance. I will say docker run hyphen it demo underscore t. Okay, and let me delete the container after that has been run, which is why I will be adding a flag -rm, and I'll run it. So now my Docker got instantiated. Now my Docker container is up and running. I can use all these commands like ls and navigate to different folders like root, which is currently having nothing. So yes, we successfully created a Docker container which is having Ubuntu operating system features in it. Okay, let me come out now. I exit. Yeah, I will go back to my Docker file and I will use the keyword run. So this run basically runs a few commands for you while building your Docker image. Okay, so I have my underlying base image, which is Ubuntu, that will be ready in my Docker image. And along with that, I want all the packages to be updated, and I want to install the package tree, which I mentioned about in the beginning of the tutorial. So I will say run apt get update and apt get install tree. So basically you can run these two commands as two different run commands, but that will be creating two different layers, which I don't want. I want this particular thing to be there in one layer, because these layers will be basically cached and they will be utilized if you are using the same layers in some other Docker images. So it is really good practice to have as many less number of layers as possible. So from Ubuntu, and then run apt-get update and apt-get installed tree. I'll come out of this Docker file and build this again with the same name, -t demo underscore tree dot. So now you can see the Ubuntu has been created as the underlying base image, and then using some cache which I had run previously, the update has been done and the tree has been installed. Now let me go ahead and run this in an interactive mode, demo tree, and again I don't want this container to exist after I quit from here, so I will be using rm, and I'll run this demo tree image. Okay, now I'm inside my running container ls. I'll go to root. I'll create a few folders. I'll say parent slash child1, and I'll create a few files in child1. Touch parent child1. I will call index.html maybe. Okay. So now my parent folder is there. Inside my parent folder there is child1. Inside the child1 folder there is a HTML file which is index.html. I'm going to run the command tree dot inside my container, and boom, you can see there are two directories and one file in this structure. Or maybe I can go ahead and create a sibling of child1. I'll just say mkdir-p parent. I'll call it as child2. Okay, and now again I'll call tree space dot, and you can see that parent child1 child2 and child1 folder is having a file called index.html. So basically there are three directories and one file in my root directory. So now you can see the difference, right? I will come out of this running container back to my local machine, and I run that command tree space dot, and that is not installed, and I'll go ahead and start running my container, and now I'll have to create those files again. But yeah, I can just quickly uh, start doing this tree in this bash folder itself, the bin folder itself, maybe tree of dot bin, right? Okay, it's going to give me a big tree, but that's fine. So you can see over here that my bin is having so and so folders, files, etc. So my running container is having the package tree with which I'm able to run a few things while my local machine didn't have it. So this is the beauty of containerization. So basically you wrap up all the dependencies and packages and applications which you want to run, and then deploy it on any machine on which Docker is installed, and yes, you're good to go. There are several more beautiful things which we can be doing and which we can accomplish using this Docker, and that we will be seeing in our coming up tutorials. Till then, stay tuned. If you have any doubts, comments, concerns, then please feel free to leave them below. And don't forget to study the theory before you start doing these hands-ons. And yes, if there are any kind of a suggestions which you would like to give to me, I'm open for them. Thanks a lot. Have a nice time. What's going on, everybody? Welcome to part 2 of the video series Docker Hands-on for Beginners, and in this tutorial we will be learning about the Docker keyword command. So what this command keyword in Docker does is it basically instructs the Docker that as soon as this particular container starts, then execute these instructions listed under U. So let's see how this works. I'll go ahead and create my Docker file, and inside this I'll create my base image of Ubuntu, and then I'll run those apt-get update kind of commands, and then cmd is the keyword. So whatever instructions I list out under this particular keyword cmd will be executed as soon as this container starts. So for now, let's print some statements on the screen. So I'll say cmd echo hello, you are now running a container, right? So cmd followed by my command echo hello, you are now running a container. I'll save this file, I'll come out, and I will build this docker build. I'll give the name command underscore docker and then say space and dot. Enter. The build started and the successfully built. Now let me go ahead and run this container. So I'll say docker run hyphen hyphen rm and command underscore docker. Now when my container starts after executing this command, it basically prints me out the statement that we just wrote in our docker file. You can see hello, you are now running a container, right? So whatever instructions you want to execute as soon as your container starts, you can just list them out under the keyword cmd or command, and that will be executed when the container starts. So if you have multiple instructions to run, then how to do it? It's as simple as that. Come to your docker file and in your cmd followed by your first command, put a semicolon and write your second command, and yeah, now I have put the ls, which basically lists me out all the folders in the current from wherever the root or the home, wherever the container starts from, right? So save this, come back, build it. It's successfully built. Now run it. So now we must have two outputs. One is the statement and two is the big list of folders like bin, home, lib, etc, etc. You can see over here. It first prints the statement that we wrote followed by ls, right? Bin, boot, dev, etc. So this is how the cmd keyword is used in Docker, and you can use it for your purposes whenever you want to execute a few instructions as soon as your container starts. All right. If you have any doubts, comments, and concerns, then please feel free to leave them below. Until next time. Bye. I appreciate your interest to learn Docker. So welcome to the part 3 of the video series on Docker hands-on for beginners, and in this tutorial we will be learning about the Docker keyword copy. So what this copy command basically does, it copies your files and folders from the local machine and puts it into your Docker image so that when my container is up and running, I have those files and folders present in that container. Let's see how we can do it. So currently I'm in a folder called 4-copy, and there is a some folder called Flask apps, which is having some subfolders again, one hyphen web app, and which is having uh, some kind of a file called init.py. Okay, so yeah, now let's go ahead and create a Docker file, build it, and so that I will be copying this particular file into my Docker container so that when it is up and running, then I will have this folder present in my container. So I will go ahead and create my Docker file, vi editor, Docker file, insert things. So use the from command to create your base image, which is Ubuntu for me. It's just one U, followed by run a command to update, say run apt get update, followed by the copy command. And here you just mention the path from source of your local machine to the destination in your container where you want that to reside. So I want to copy the Flask apps folder from my current folder here to root folder of my container, right? So I want to copy my Flask apps folder from my local machine to the roots folder of my container with the same name, right? So I'll save the file, come out and build this. Say docker build hyphen t, give the name. I will give copy docker and then dot. So the build started and the build is successful. Now let me go ahead and see if the image has been created or not. Say docker images. And yes, I can see my copy docker image created. Okay, now I will run it. Say docker run hyphen it so that I have an interactive mode open, hyphen rm so that my container is deleted instantly the moment I stop it. And then I'll say copy docker. Now it started. Let me go to the root folder. I'll say cd root and I'll say ls command, and you can see my Flask app folders is present. Let me navigate inside it and see if it has been copied iteratively or not. Yes, I have my one hyphen web app folder as well. Let me go inside this one app folder and see if my init.py file is there or not. Yes, I am finding my init.py file as well. So this is how we make use of the copy command to copy the files from my local system to the Docker container so that when my Docker container is up and running, I have those files and folders over there. Go ahead and do more beautiful things with Docker. And if you have any doubts, comments, and concerns regarding this tutorial or any previous tutorial or future tutorials, then please feel free to leave them below. Until next time. Thank you. Hello everybody. Welcome to part 4 of the video series on Docker hands-on for beginners, and in this tutorial we will be learning about the Docker command or the Docker keyword add. So add is very similar to copy, but it has a couple of more functionalities like it will extract the contents of your compressed file or folders and then put it in your Docker image. Also, it has the ability to download the files, extract it, and again put it into your Docker image. Let's see how this add commands work. So I'm inside my folder 5-add, and I have a tar.gz compressed file present in that folder. So now I'll go ahead, create a Docker file. Say I create your base image from Ubuntu, then run apt get update. Now use add. Say flask underscore apps dot tar dot zz. This is the source, and the destination on your Docker image will be inside my root folder. That's it. Just give the folder in which you want things to be extracted, and the add will do it for you. Okay. Let's write a CMD to see if the folder will be present or not. So when this particular tar.gz will be extracted inside my root folder, the folder name of the extracted it will be the flask underscore apps, right? So I can just write a simple check here. I will say if test hyphen d of slash root slash flask underscore apps, then echo the folder has been extracted to your container, and then say fee. Okay, so I have my base image, I have updated, and I have used my add command to copy the compressed file in an extracted format to my Docker image, and later when my container starts I am giving a command to see if that directory exists or not. So let's go ahead and build this. I will say docker build -t and I will give the name add docker and a dot. So it started and the build is successful. Now let's go ahead and run. I will say docker run -rm add underscore docker, and yes, you can see that the test passed. The folder has been extracted to my container, correct? So what I can do is I can go ahead and run it in an interactive mode as well. So I will say docker run -rm add underscore docker, and here I can give some commands. What I'll do is I'll give the command as ls slash root slash flask underscore app so that I can get if there is something inside this folder as well. So okay, I think I created some mistake, or maybe the command is not proper. I don't think I should be having this double quotes maybe. Yes. So I'll just run it again because that was messy. So double quotes was not supposed to be there. So I'm using a ls command inside my root of the container and flask apps of my containers and see if there is some folders inside it. Yes, there is some folder and that has been successfully extracted onto my container. And this one hyphen web app folder is having something called as init.py, right? So let me just go ahead and give that to. I will say check and tell me what is inside my this folder too. And it should give me the output init.py, then the extraction has been successful. Yes, and the output is init.py as you can see it over here. So super cool people. This is how we use the add command to copy files from your local machine to your Docker image. Here you can even give any URLs, which is a direct download of your files, and that works like a charm. Always, but it is not recommended to use add for downloading things. Instead, they say that the best practice is to use the wget or the curl to download it first and then run a few commands to extract it to the required destination and not add. So you can have these practices that wherever there are local files which are already downloaded, you go ahead and use add. Otherwise, go with the uh, run usually to wget and curl, then go ahead and extract things. But yeah, these are the features and functionalities of add, similar to that of copy. I hope you got the essence of these things, and I'm looking forward to do some really, really good things ahead with all these things. If you have any doubts, comments, and concerns till this or about the next videos that I'll be making on Docker keywords and Docker stuff for beginners basically. And if you're expecting something to make, then please do leave them in the comments below. Until next time, thank you. What's going on, everybody? Welcome to the part 5 of the video series on Docker hands-on for beginners. And in this tutorial, we will be learning about the Docker keyword or a Docker command working directory. So this working directory specifies a default directory in the Docker images wherein we can perform a set of instructions. So what might be the scenario or a use case for this? Imagine you have a set of instructions which you need to execute inside a particular directory, inside a particular folder, and it won't be convenient to mention the complete path to that folder every time you run an instruction. Imagine you have 10 instructions to run in a particular folder, and in all the 10 instructions, if you have to give the file or the folder path, then it's kind of tiresome and it's not that convenient. And in case there are any issues over there, then it might lead to other errors, right? So if there was any way where I could set a default working directory for all those 10 instructions, then that would be really awesome and that would make my work really, really easy. And work directory command in this Docker is going to facilitate us with that ability. So let's see how we can do this. I'll say vi docker file, right? I'm in my Docker file now. Say I for insert and from Ubuntu. I created my base image. Now, if I had to create a few files in one directory and few files in another directory, say for example, I'll say run in my root. I wanted to create one file. I'll say touch test file 1.txt. And if I wanted to create another file in the same path, I'll say test file 2.txt. Similarly, run touch slash root slash test file underscore 3.txt. And I wanted to create a few more folders within my root folders and add the same files over there. Then I will have to write run mkdir hyphen p slash root slash test folder slash child folder child one. And similarly, if I want to create one more directory over there, I would say slash root slash test folder slash child hyphen one, two. So isn't this kind of a very tiring kind of a instructions to write the complete path every time? So what we can do instead is, when I know that my root folder is going to be my default working directory for those set of three instructions, I can go ahead and specify work directory slash root slash. And I can just make these syntaxes as dot slash, dot slash, and dot slash. So within my root directory, these will have created because I have set my working directory to root. And working directory root will be the same for all the instructions that are following it unless you change it. So now I know that I have a working directory of test folder within my root folder. So I can just have one instruction to create that folder, and then I can set my working directory to that folder. I will say work dir slash root slash test folder. Okay, and now I'll go ahead and do this make dir whatever it is. Test folder has been there. I'll say create over there. Say one, and another command would be run mkdir dot slash child underscore 2. So now the working directory will be slash root slash test folder. Let's go ahead, build this file, and then see if I have three text files in my root folder and two folders in my root test folder. Okay, I'll say docker build hyphen t mm, work dir underscore docker will be the name of my docker image. So I started building, it's still building. So there are so many unwanted layers actually created, but for your understanding, I'm doing it, that's absolutely fine. So now let me go ahead and run this in an interactive mode, and I'll say hyphen hyphen rm because I don't want this container to exist anymore after I close this, and I will say workdir docker because this is the name of the docker image. So now I'm inside my docker, right? You can see I'm already in my test folder, but let me go to root first. So now I'm in my root. I'll say ls. You can see there are three files which are created, that is test file 1, test file 2, and test file 3.txt, and a test folder. And within this test folder, I should have two folders. I will say cd test folder, and I'll say ls. You can see child 1 and child 2 are ready. So this is how you can create different stuff within your working directory by specifying the working directory. You can see the last working directory which I had set was test folder, and when my docker started over here at this line, you can see that by default I was in the test folder because the last working directory that I had set in my docker image was root test folder. So if you want to change this, again you can just write another work directory at the end mentioning whatever folder you want to be at when your docker starts, and go ahead. So this is how work directory used. Basically, work directory sets a default working directory in your docker image so that when your container starts, in that docker image, in that docker container folders, all your operations will be executed while building and while running. Okay, so I think work directory is quite clear. You can go ahead and play around with this. If you have any comments, doubts, concerns, then please feel free to leave them below. Until next time, thank you. What's going on, everybody? Welcome to part 6 of the video series Docker Hands-on for Beginners, and in this tutorial we will be learning about the Docker command entry point. So what does this Docker command entry point do? It works very similar to CMD, that is running the instructions the moment the container starts, but the only difference is, which I found out, was we cannot override the instruction under entry point, whereas we can override the instruction which we have given under CMD. So we'll see how entry point works and what is the best practices for that. So what I'll do is I'll navigate. So cd docker training folder 7 hyphen entry point, and then I'll say vi docker file. Okay, actually I had practiced it, so I'll just first delete that so that we can rewrite it freshly. I'll say rm docker file. So the docker file has been removed now. I will say vi docker file. Okay, say insert and create the base image. I'll say Ubuntu and then run an update. Say apt get update and then say entry point, and under entry point you can write any command, but for now, for our understanding, what we will do is we'll write ls. So I'll save it and I'll become a sudo user, that is a super user. It is necessary to be a super user while running these docker commands because docker engine will be running as a daemon, and daemon should have the administrative privileges basically. So I'll build this docker image. I'll say docker build hyphen t. I will say entry docker as the image name and dot and run. So now my docker image has been successfully built. I will go ahead and run this. I'll say docker run hyphen hyphen rm docker, I mean entry docker is the name, right? So I will have to give entry underscore docker. So when I run this, you can see that all my folders under that root has been listed out like bin, boot, dev, etc, etc. Okay, now what we'll do is, let me try to override this. I'll say docker run hyphen hyphen rm entry docker. Instead of ls, let me try printing out the current working directory. I'll use pwd and I'll run. So you can see nothing changed. It did not give me slash as the output. Instead, whatever I had instructed to do under the entry point, it did it. It listed out the folders in it. We will do the same thing using cmd instead of entry point. Okay, I'll say vi docker file. I'll come at that point. I'll just comment this out and I'll use cmd and ls. I'll save this file. And now I'm going to build this again. Now my docker file has been successfully built. Now I will run this. Okay, now when I run, again it is going to list me out the folders inside my root. And now let me go and override this. I'll say pwd. Be aware that my ls command is under cmd of the docker command and not by entry point. And previously we saw that we couldn't override our entry point command, but now where I have used cmd, I will be able to override. So instead of listing out the folders inside my root, it is going to give me a slash, which is the current working directory. So you can see here the output is slash, which is the current working directory. And I could easily override that ls, which was listed under cmd, from my command line itself. So the best practice would be, if you want something to be executed right after the container starts, where the user could not override it, then go for entry point. And you can use the flags which that entry point command would need under cmds, like if there are any multiple flags like 2 3 flags and you want the customer or the user to choose it, then you can just put them in cmd, and the main command which you want to run the moment the container starts, you can just write it under entry point docker command. I hope the Docker command entry point is clear to you. If you have any doubts, comments, and concerns, then please feel free to leave them below. Until next time. Thank you. What's going on, everyone? Welcome to part 8 of the video series on Docker hands-on for beginners, and in this tutorial I'll be teaching you about the Docker command env. So basically this is all about setting environment variables in your Docker image so that when the container starts you can use those environment variables for different purposes. You know the use case of the environment variable, so yeah, how we can achieve that in Docker, let's see. So I'm in a new folder called 9-env, and I am going to go ahead and create a Docker file. I'll say and then I will be creating the base image. I will say base image is Ubuntu, and then let me run the update just for the sake. I'll say run apt-get update, and followed by this I will go ahead and create the environment variable. I'll say env work directory, that is work directory. I can either give a space and give the value of this key, or I can go ahead and give it with the equal to. Both are valid. Like the other way would be like this: env work dir. Even this would work. So now I created an environment variable called as the work dir, and the value for that environment variable will be /root. That is, root is going to be the working directory. Now I can go ahead and use that work directory anywhere inside my Docker image. So I will actually go ahead and write my working directory Docker command, followed by I'll give this. The using of dollar symbol is very important because that's how you represent the variables, right? So yes, this is cool. We are done. I'll save this Docker file, come back and build the image. Say docker build -t, and then say env underscore docker and a dot. Now the build started and the build is successful. Now I'll go ahead and run this in an interactive mode, and the moment my container starts running, I will go ahead and run the command pwd, that is the present working directory, and we will be able to see that it will be the root folder. So let me run docker run -rm -id, that is the interactive mode, and the name of the Docker image was env underscore docker. So I'm into my Docker now, and you can see I'm actually in my root folder. I will say pwd and say enter, and you can see the root. This is what is the working directory which we had set there, but we had not explicitly mentioned the working directory to be the root. Instead, we had mentioned it in the form of the variable, the environment variable, which stored this value. So this is how the env, or the setting of the environment variable, looks like. You can go ahead and set multiple environment variables, so that shouldn't be a problem. Play around with this, and yes, create awesome stuff. If you have any doubts, comments, and concerns about this whole tutorial, then let me know in the comments below. Until next time, thanks a lot. What's going on, everybody? Welcome to part 9 of the video series Docker hands-on for beginners, and in this video tutorial we will be learning about the Docker command or the Docker instruction label. So label helps you to add metadata to the Docker images, and labels actually allow you to do pretty interesting things with your Docker images. Image labels will let you attach some text-based data to your Docker images so that you can then filter your images based on these labels or look up this data in any custom scripts or tools that you write. You can basically store your build information, give credits to the authors and the people who are maintaining your project inside that container, or display the licenses and its information. Also, you can organize your images by any criteria you think. That is, like, there might be some kind of a information that needs to be stored for a kind of a Docker images you are creating for your organization. So you can put up that information over here so that they can be filtering later, or you basically get information about the information that is stored inside your Docker image, right? So information about information is nothing but the metadata. So label is used to put some metadata for your Docker. Great. Now let's see how we can do and what we can do. we'll go ahead and create a Docker file. It's vi Docker file. So I'll have to put a base image. I'll just say from Ubuntu, and then followed by that, we will go ahead and write the label. The connectivity seems to be pretty slow. Okay, it came now. Great. So the way to write our labels are, say a label followed by key value pairs, right? I will say description equals. If I'm using spaces in my values, then it is recommended, or it is rather compulsory, to use double quotes, right? I will be writing here some description about this Docker image. This is the Docker image to showcase the usage of label Docker command, right? So I now have this label, and I can just go ahead and save my Docker file and build this. I'll say docker build hyphen d. What was that label, right? So label underscore docker and a dot. So now my Docker engine started building this, and yes, it has been successfully built, right? There won't be special execution stuff for this, and there's also a way to give labels to your Docker. That is, while using this build, you can actually say hyphen hyphen label hyphen equals, and then you can, I mean, hyphen label, and here you can actually use some kind of a key and then say some kind of a value, and then build this. Should work properly. I guess the hyphen t has to come just beside or before the name we gave, right? I think the docker build hyphen label, and here is where I need to put my t. So let me enter. So yes, you can see over here the label key has been again assigned as a one of the labels for this particular Docker image. So you can go ahead and write the Docker instruction inside your Docker image also, or else you can also write it in your command like this. That is docker build hyphen label followed by your key values. You can put multiple key values which will be space separated key values, or you can also write multiple labels, shouldn't matter. So I hope the idea about label is clear. Yet if you have any doubts, comments or concerns, then please feel free to leave them below. Until next time, bye. What's going on, everybody? Welcome to part 10 of the video series on Docker hands-on for beginners, and in this tutorial we will be learning about health check. So what is health check? Health check is a Docker instruction or a Docker command that helps us to see if my applications in the Docker container are running fine and not consuming unwanted resources or resources in an unwanted way, right? So we'll be running a few commands to see if things are running fine. Otherwise, we are going to exit or stop the containers. So let's see how we can do it. So currently I'm inside my folder health check, and I am going to go ahead and create my Docker file. And yes, let me remove all these things. I create my base image. I will say from Ubuntu, and I will run commands which are apt get update, right? After this, I'm going to write a command called health check. So health check is going to take a couple of parameters, that is an interval. At what interval do I need to check my health? I'll say every 5 seconds. And then it will also ask you what is the timeout, that is if the action which you ask your container to take to see if your health is good or not. So you need to give a timeout, that is if at all by running a command to check my health, it gives me the result within 3 seconds of time, then my container is healthy. If at all that command is taking more than 3 seconds, then my container health is not good and you need to exit, right? And also you need to give retries because sometimes something might have happened and the command might take a bit more time than the timeout to execute. So retries is a count, and you can specify any number of count you want, which is reasonable, feasible, and favorable for the applications that are running on your container, right? If these are there, then you need to run some commands. So for now, let's assume that I want to see that if I'm able to cd to some directory called label cd, then my health is good. So basically, this command should give me some outputs within a span of 3 seconds at every 5 seconds of time. That is the interval. And if this doesn't work, then attempt twice, otherwise exit with the code 1. Okay, so 1 is used to indicate that there is some issue, and 0 is used to indicate that things are fine. So this is the command to write my health check. I'll save this Docker file. I'll come back and I'll say docker build -t health underscore docker, and I build it. So now my Docker container is successfully built. That is, the image is built. I'll go ahead and run it. I'll say docker run -t and what was the name? Health docker, right? So currently I'm inside my Docker container, and let's go and see what things are going on. So okay, before that we might have to give that a name, right? So yeah, there's a small thing which I just missed. So docker id, let me kill it. Docker kill. Super. So I come back, I rerun that. I will say with a name this time. So you can give names to your containers also. So I will give the name as health underscore docker, just the same, like, okay. So now it is running. I just open another terminal and I inspect this. I'll say docker inspect health underscore docker, and it will give you a big JSON file. But we are interested in something called as state. So just look for that thing, state. Yep. You can see here there's a state, the status is running, and there's something called as health. So the status is started, and the failing streak, it's the first one, and you can see the log that it executed with 1 because it couldn't do cd to label cd because this folder never existed inside my container. So like this, you can go ahead, write your commands to see if your health is fine, if the health of the container is fine, and if it is not working fine in those intervals with those many retries within that timeout period, then yes, you can always exit your container. So this is all about the health check in Docker. If you have any doubts, comments, and concerns, then please feel free to leave them below. Until next time. What's going on, everybody? Welcome to part 11 of the video series on Docker hands-on for beginners, and in this tutorial we will be learning about stop signal. So what is stop signal? In order to stop a running container, we use a command called as docker stop the container name, and this by default sends the signal sig term, right, which is the kill code of 15. But you can always go ahead and modify what interrupt or what signal is sent to the Docker daemon to stop this process. So you can mention it as sigkill or sigterm or sigint, whatever you want. So for that purpose, stop signal will be used. So let me go ahead and create my Docker file. I'll say vi Docker file and set the base image, which is Ubuntu. And just for formality, for now we can run this, say update, and then you can say stop signal. And what signal do you want to send when I stop this Docker container, running Docker container? So I will say I need sig kill and not sig term, which is the default one, right? So I'll save this and I'll go ahead and build this Docker image. I'll say docker build -t. I'll give the name as stop docker and a dot. So my build is successful. I'll go ahead and run this now. I'll say docker run -it --name stop docker. This is the name of the container, and this, the second stop docker, is the name of the image, right? So now my container is running. I can come over here in a different terminal and I'll say docker stop docker, right? So when I execute this command, it basically sends a signal to the Docker daemon to stop this running container, Docker, right? So while sending the command, instead of sending sig term, which is the default one for this stop, it now sends sig kill because that is what is defined in my image, right? I press enter and the Docker stops this container. So if you go and see in Docker PS, there are no containers that are currently running. Correct? So this is all about stop signal in Docker. If you have any doubts, comments, and concerns, then please feel free to leave them below. Until next time. Bye. What's going on, everyone? Welcome to part 12 of the video series on Docker hands-on for beginners. And in this tutorial, we are going to learn something about volume. So after having played around with Docker containers, so you might have observed one thing, that once you run a container and you again run the same Docker image, that is, you again instantiate a new container of the same Docker image, the intermediate files which you might have generated or the scripts running inside might have generated are basically lost. You don't get them back. The problem is the storage is not persistent, and this is going to address that problem and provide you a solution. Well, before jumping in what exactly this does, I would like to share a good news that my YouTube channel just crossed 100 subscribers. So thanks all of you for supporting and encouraging me. That kind of motivates me to create good contents and share my knowledge and of course learn a lot from you guys. So yeah, how do we have persistent storage which can help containers retain the files or any data which it generates in its memory, and how containers can share the data among themselves, right? So let's jump in and see how we can achieve that. Well, the process is simple. I have a container or a Docker image right now. That's the busy box. I'm going to run it with some name and I'll show you how I can create a volume in it. So I'll say Docker run in interactive mode. Let me give the name of the Docker as busybox underscore one, and I'm going to say hyphen v. Hyphen v is the flag we use to add a volume, and I'll say data. Let data be my volume, and I'm going to run the Docker image busybox, right? I'll say enter. Now when I say ls, I'm inside my container now, by the way. You can see that the volume has been created, the data has been created. So I'll enter inside, I'll say cd data, and I'm going to create some file, a temporary file called test.txt, correct? And if you do the ls again, you can see that my file test.txt has been created. I will come out of the container. I came out of the container now. Okay, and I'm going to instantiate a different container of the same Docker image. I will say docker run hyphen it hyphen name busybox underscore 2. As of now, I'm not going to create any volume, but I'll run the same Docker image, right? Busybox. And I'll do an ls. You can see I don't have anything like data. So basically, even though I am running a container of the same Docker image, the file which I just created is not reflecting in my new container. So what I can do, I'll exit as of now, and I'm going to remove that container which I just created, that is busybox2. Okay, I just deleted it, and I'll come back, run the same command like docker run hyphen it, give the name as busybox2, but along with that, what I'm going to do is add one more flag and say volumes from, and give the container name of the previous one, busybox underscore one. Okay, and run it. Now see the magic. When I do ls, the volumes which I had created for this container busybox1 is reflecting here. The data has come. I haven't created any new volume here though. I just said I need the volumes from busybox 1 to be reflected in busybox 2, and the Docker image for this same is busybox. So even if you enter inside the data, right, and do an ls, you can see my test.txt comes. So this is how we create persistent storage in Docker environment or in container environment. And this is how you can share your files between the containers. So if you have some two APIs that are running in two different containers which communicate with each other and might require a few data files to be shared among them, then this is the way, right? So this is how we achieve persistent storage. In our next tutorial, I'll teach you about something called as mount, and after that we are going to learn a really interesting topic on how to deal with networks among these containers. So as far as volume is concerned, if you guys have any doubts, comments or concerns, then please feel free to leave them below. Until next time, bye. What's going on everyone? Welcome to part 13 of the video series on Docker Hands-on for beginners, and in this tutorial we are going to learn something about mounting a volume. So if you want to use any of the folders or files that are available in your host machine in your container so that you change in either of the places and changes are reflected in both the places, then you might have to use something called as mounting the volumes. So how shall we do it? We see it now. Uh, Let me say that I'm using a container, maybe busybox, or let me take Ubuntu for an example or demonstration here, and let me mount this folder Flask apps in my container. So how do I do it? I will say docker run -it, which is the interactive mode, and I will say -v, and I have to give the path. So I have to give the complete path always. I will say present working directory slash Flask apps, right? And I have to say colon, and wherever you want to mount it, you can just give the path, and this path is going to be the path inside your container, right? So I'll just say Flask apps and I will run Ubuntu, correct? So I'll press enter, and when I do ls, you can see that inside my container also my Flask apps folder is present. And if you even look inside it and do an ls, you can see my subfolders are also copied. And the interesting thing that I want to show is currently I'm inside my Flask apps now, which is having a one hyphen web app, and I will create a new file called test.txt. This I created inside my container, right? Now let me go to my host machine. This is my host machine where I have Flask apps folder. I will go inside my Flask apps folder and do an ls. You can see this new text file test.txt, which I created inside my container, is now reflected on my host machine as well. Now what I'll do is I'll just delete that file. Right, now come back to the container and do an ls again, and you can see that file is removed. It is not existing anymore. So basically you are sharing your host folder in your host machine as well as containers. So if you want a way wherein you can do changes at different places and you want that changes to be reflected at all the places, then you might have to use mount. And how we do it? We do it this way. Docker run -v, same as creating a volume. Give the path of your host file and put a colon, and again give the path inside the container where it needs to be mounted, and run your Docker image. So I hope mounting is really understood by all clearly, but yet if you have any doubts, comments or concerns, then please feel free to leave them below. Until next time, bye. What's going on everybody? Welcome to part 7 of the video series on Docker Hands-on for beginner, and in this tutorial we will be learning about the Docker command or the Docker concept of expose. So expose is basically used to expose the port number of the container to the physical port of your host. That is, you have an external port number to which your machine will be connecting and communicating with the outer network, and inside your host, you will have your container running, which will have an application running at a particular port number. So you map an external port number to an internal port number of your container. So let's see how we can do that. So firstly, I'll have to write my Docker file. Currently, I'm inside my folder called expose, and I have two files. One is my Flask application, and another is my requirements.txt, where I'm going to install a few Python dependencies, which are nothing but Flask. Okay, so I'll be teaching you how to do this expose in this tutorial. Let me go ahead and write my Docker file. I will say from Python version 3, and I will use the on build. So on build, what this does is after creating the layer of the Python version 3 dot something, it is going to pick the what you can say the packages that needs to be installed from the requirements.txt file in this current folder, and install those packages as well in your Docker image. So I have my Python 3 hyphen on build ready, and that will be serving that purpose. Then what I'll do is I'll copy the file, copy init.py to root folder of my container. I will name it the same as init.py. Then in my init.py, I have made my Flask application to run on port number 5000. So now I would like to expose that 5000 port. So say expose port 5000, and followed by use the entry point command to invoke that file and have it running. Say python -root slash init.py. So I'm done. I have my Python 3 built, and I'm using the on build command, wherein it is going to pick my requirements.txt and install all the packages that are listed out in requirements.txt file. Then I have copied my init.py to the root folder of the Docker container, and then I'm exposing port number 5000 because I'm running my Flask application at port 5000, and then using entry point I'm going to invoke that Flask application. Okay, so I'll save this file, come out, I'll build the image. I'll say docker build -t expose underscore docker and a dot. So my build started. So you can see here it is picking up the requirements.txt, it's installing them, and basically it's installing using cache because I had run this particular Docker file a couple of times before, and then it is exposing 5000 port number, and the entry point has no issues, so it starts. Now let's run this. Docker run --rm. Now there is a trick. We have to use -p flag and tell which is the external port that will be used to communicate with this internal port. So I will be using 8080 as my external port, and I will map it to 5000 internal port, which is exposed. Okay, the first one is the external port, the second one is the internal port. So -p is the flag that we need to use along with docker and command, and then give the Docker image name, say expose docker. I'll say enter. Now you can see that my Flask application is running on HTTP 0.0.0.0 at port number 5000, and I am mapping this 5000 to port number 8080. Correct? So I'll come to my browser, and this is my fully qualified domain name FQDN, and I'm going to connect to this using 8080 port number, and this 8080 port number is going to be mapped to 5000 port number where my Flask application is running. So basically I must get the web page content of the Flask application that is running on my host inside my container. So you can see, welcome to Flask application running in a container. So we successfully did this. So we had our Flask application running inside a container at port 5000. We mapped it to the external port 8080 using expose command, and yeah, we successfully hosted a Flask application inside our container. I hope the Docker command expose was clear to you. Yet, if you have any doubts, comments, and concerns, then please feel free to leave them below. Until next time. What's going on, everybody? Welcome to the tutorials on Docker Hands-on for Beginners. After learning so many things about Docker and Docker containers, now it's time we understand some networking aspects. And I don't want to bore you guys or confuse you guys by explaining everything in one single video tutorial, which is why I'm going to split it in multiple tutorials. And so yeah, let me welcome you all to part 14.1. And in this tutorial, we will be learning how to create a network in my host to run my containers, right? So the idea is simple. I must have a range of IP addresses so that I can assign it to my containers. For the purpose, we will be using CIDR, that is classless inter-domain routing. And of course, I'll be creating a private subnet, and later we will start assigning IP addresses, and we will use the concepts that we have learned earlier, like exposing the port numbers and have our containers communicate with each other. Also, have my host machine communicate with the containers it is hosting, right? So let me go ahead and show you how I can create a subnet. So I will say docker network hyphen hyphen subnet, then give your CIDR, the subnet range. I'll say 172.28.0.0/16. So to help you understand this subnet, I can say that this is a CIDR notation. You can go ahead and read about it, but in simple terms, I'm going to explain it. This 172.28.0.0/16 is a CIDR notation where it says my first 16 bits of the IPv4 address is reserved for network part, and the next 16 bits of my IPv4 address is reserved for host addresses. So I will have 255 into 255 number of hosts to whom I can assign the IP addresses with this range, right? So yeah, and followed by this, give your network a name. I will say Teddy network, and I say enter, and sounds that something has gone wrong. What is it? Docker network command. Yeah, I'm so sorry. I need to use the key docker network create because I'm creating a subnet, right? So docker network create, give the subnet CIDR and give your network a name, and then say enter. It creates you your network. And to see if that has been created properly or not, you can just go ahead and say docker network ls, and you can see here with some network ID, my network, that is the Teddy network with a bridge type of connection, has been created. So there are multiple type of networks that you can create in your host machine. Like one can be bridged, another can be NAT, that's the network address translation, and another can be host only. I expect you guys to go ahead and read about those things, but for now, the scope of this tutorial is how we can create a subnet so that we can assign IPs to different containers and have them communicate with each other. So this is how we do it. Docker network create subnet your IP range. This can be anything, right? So this can be like 10.x.x.x series or 192.168.0.0 series or something like this. Those which are reserved for private IP addresses, right? So you can just give that subnet and have your network ready. If you have any doubts, comments, and concerns, then please feel free to leave them below. Until next time. What's going on, everyone? Welcome to part 14.2 of the video series on Docker Hands-on for Beginners. And in this tutorial, we will be learning something more on Docker networking. So I will now show you how I can assign IP addresses to my containers, have them running, and how I can ping from my host machine. So it's simple. I will say Docker run in interactive mode. I will give it some name. I will call it as app container, right? And I will be giving it an IP address hyphen hyphen IP, and I will say 172.28.0.10, and I will connect it to my net which I just created. You can go ahead and see my previous video if you have not seen, and the Teddy network, which I had created using another Docker command called docker network create, right? And then run my Ubuntu Docker image. And I'll say enter. Now I'm inside my container. And if I say if config, hopefully the command exists. The command doesn't exist yet, so I can go ahead and just say update first. And I will say apt get install nettools. Right. Now if I say ifconfig, you can see the IP address that I just assigned to my container comes up. So inside my container, I am running my command ifconfig to identify my IP address, and it shows exactly the same IP address that I had assigned out there. Now I'll come back to my host machine and I will try to ping it because it is running it there currently, right? I can just show you. If you do docker ps, you can see that my app container docker is running. It's up since about a minute, correct? Now I'll say ping 172.28.0.10 and I'll give the count as 5, ping 5 times. You can see the ping pong is successful. It is sending 64 bytes of packets and it is receiving the response back. So yes, this is how you create a container, assign it an IP in the subnet that was created within your network, the bridged one, and inside your container you can go ahead and check for its IP, and you find that assigned IP also, you can have it pinged from your host machine. Maybe at this point of time I can show you one more thing, that is you come to your etc/hosts file and you make an entry about it, that is 172.28.0.10, and call it app machine. That is, let me give this as my host name, right? And I'll save this file and come back here and say ping app machine and say enter. Again, it successfully pings it, right? So if you have your host name for the container, then you can add it over here in this etc hosts file. Otherwise, with the IP address, you will be able to communicate with it. In our next tutorial, we will just see how we can communicate from one container to another container, and hopefully we will be winding up this series. If you have any doubts, comments, and concerns regarding this tutorial, then please feel free to leave them below. Until next time. What's going on, everyone? Welcome to part 14.3 and last part of the video series on Docker Hands-on for beginners. And in this tutorial, I will show you how I can make two containers communicate with each other. So if you look at Docker PS, that are what containers are currently running, I have one of the containers, that is app container, running at IP address 172.28.0.10, and I'm going to start or run one more container running at a different IP. I will say docker run -it. I'll give the name as node1, and I'm going to attach it to the network of Teddy network, and I will give it an IP of 172.28.0.11, and then run the Docker image, right? Did I miss anything? Probably not. So inside this, I'll just say ping will not be installed in this, so I might have to update this image. So the container, basically, I'll say apt get update first. It got updated. I will say apt get install net tools, right? And also to ping, I might have to install apt get install inetutils hyphen ping. Say yes, and yep. Now we know that two containers are currently running. If you do ifconfig, this is at 172.28.0.11, and the other container here is 172.28.0.10. So from this machine, I will say ping 172.
28.0.10 and I give the count as 5, you can see it is hitting my other container that is running and getting the response. So like this, you can spawn multiple containers, give them an IP address in the subnet you have created, and have them communicated with each other. So what might be the advantage of this? See, there is something called as microservice architecture that is getting great traction in the enterprises and other software development areas. And there, they basically isolate a feature of a bigger software application, and each application will communicate with other application or other feature via API calls. And imagine, let's just give you a very simple example. We have Facebook, right? And in Facebook, we have different kinds of posts. One is the text posts, another is the image posts, and one more might be the video posts. So I will have one container running and for database, one container for post texts, and another container for processing the image posts, and another container for running the video posts. So if I encounter a huge traffic of image posts, then I will duplicate or scale up my containers that are running my processing for the posts of images, right? And I will have them communicated with the container that is having my database, so that even if a person who wants to hack my stuff and spoil things will be difficult for him, and even if I want to go ahead and add a feature that will be easy for me, and even if as a developer I want to go debug something, then that will be extremely easy for me because I know which container to go and what code to change, right? So containers are best suited for implementation of the microservice architecture, and containers are really really good for shipping our softwares from one host to another host without having any issues in execution of the same. And in today's tutorial, we saw how to communicate from one container to another container, right? So I'm going to wind up this series here, and I'm working on some kind of a project that involves these Docker containers, and hopefully once I'm successful in it, I'm going to be successful in that's a different story. So once I'm done with it, maybe, right, I'm going to create a tutorial on how I implemented that, and I'm going to share my experience and the fun I had doing it with all of you guys, and I'll help you understand and implement the same again. So if you have any doubts, comments, concerns about anything regarding whatever I taught or whatever I shared with you guys, then please feel free to leave them below. And also, any suggestions are welcome. Please let me know if you guys enjoyed this series, and do not forget to share because sharing is caring, right? So, all the best. Have fun with Docker. Thanks a lot again. Bye bye.